Thanks everyone for joining. I think we have a pretty good crowd. We'll get started with the intro here. So my name is Didier. I'm the tech lead for the HPE developer community. Together with me is Mathieu and Fred from our team. They will be helping with questions and the chat and the Q&A. Today, this is our meetup for the month of May. Together with me is Isha, and she will be talking about HPE machine learning development environment and the open source machine learning advantage. Before I hand over to Isha, I will go through a few housekeeping items, pretty easy because if you've been following us, you probably know this by heart now. But as you know, this is part of the Meetup series, which we started in January 21, and this is a monthly program. We go in depth on technology in these sessions. We don't have a session for June. I'm working hard on it, but I might have to call it a failure for June, mostly because of the planning with HPE Discover taking a lot of energy from potential speakers. But I'm still hoping for something late June, but let's see. We'll announce this anyway on the Meetup page on the developer.hpe.com website. We also have another series which you might not be familiar with, called the Munch and Learn, and this is maybe a little more thought leadership type of session, vendor and product agnostic. So we had a very successful ChatGPT session last week with record-breaking attendance. We have one that could be also interesting for you about digital twins, metaverse, and augmented reality. So this is done by HPE folks, and we'll have 3 speakers, and that will be June 14th. So this is also available, registration link on the Munch and Learn page on our website. I forgot to say that on the Meetup and the Munch and Learn page, you will find replay links for all the past sessions. They're all videos on YouTube, but we have the list of them available directly on this page. And in most cases, the slides are available as well in PDF. And we'll make this session available as a video less than a week. So let's say maximum Tuesday next week. And we'll have also the slides from Isha as a PDF. In addition to that, I will say that we are trying to do our best here in the HPE developer community to help with skilling up developers. And we have a number of items that complement the technology talk. One that is really important is the workshops on demand. These are workshops that you can book free of charge, 24/7. They're just a Jupyter notebook, a bunch of Jupyter notebooks you can access over the internet. We provide a framework for you to register. We have in our catalog today 33 workshops. A good half of them are based on open source technology, things like Docker, Kubernetes, many other things. There's one, for example, called Machine Learning 101, which is really in context of this talk today. Give it a try, provide us with feedback. We continue to update and add content to this catalog of workshops. And this is available for internal and external people, so feel free to use. The HPE developer community is a community, so we need you to help contribute and amplify. If you can continue to join our talks, that's great. If you can invite others, that's even better. If you have, for example, customers you'd like to invite because the subject is pretty much in line with what they're doing, feel free to forward the invitation. We have a monthly newsletter which amplifies everything we do. You can register in the URL right there. You can also invite people to join. It's a good way to keep track of what we do in the HPE developer community. We have an external Slack workspace that we maintain for developers, and this is again externally accessible. And we have channels for about everything that has an API or some sort of integration capability within HPE. So you can join that, and you can invite customers to join that as well. We have a Twitter account you can follow as well. If you're a subject matter expert, we are really interested by you. You can help us and contribute to blogs. We have a very open source based mechanism for contributing blogs. We use an open source CMS. We use Markdown, we use GitHub. So it's pretty much technology that developers are very familiar with. Reach out to us if you want to deliver a meetup on a subject that you're an expert. You can also help us in events such as Discover. For example, we run a massive Hack Shack there, and we always welcome people in the staff. And if you are interested in helping us build a workshop on demand on the topic that you are an SME for, then reach out to us. Again, we have a platform that is easy to extend and add content to. So feel free to reach out to the team. So this is kind of a link to all the possible contacts you can use for reaching us, whether you prefer Twitter or Yammer for partners or Jupyter Workshop on Demand and our Slack, internal and external. Don't hesitate. Developer.hpe.com is our website. This is where everything starts. And with that, I would like to hand it over to Isha for the real content of the session. Thank you.
Well, really glad to be here. I'm really excited to be speaking to you all on HPE machine learning development environment and the open source advantage. My name is Isha. I'm a machine learning developer advocate at Determined AI. I've been here for almost 1 year now. Prior to this, I was working at a federally funded research and development center working on adversarial AI. So basically red teaming, computer vision algorithms, and other AI algorithms to make them more robust to adversarial attack. And today I'm going to be talking about MLDE, or Machine Learning Development Environment, which is the enterprise version of Determined AI. And I'm also going to be talking a little bit about why developing open source infrastructure is key to driving the ML industry forward. So with that, let's go ahead and get started. So what is Determined AI? Determined AI is a deep learning training platform, and it is an open source project. It was open sourced in 2020. And it was acquired by HPE in 2021. And the goal of Determined AI is to make it dramatically easier for machine learning engineers to train their models instead of focusing on DevOps and grunt work. And so why is there a need for this platform to begin with? Aren't ML engineers just software engineers with a focus in machine learning? So while these types of engineers do exist, the group of people that I'm talking about today are also commonly referred to as data scientists. And these are people that largely focus on training the model. So this is a different type of work entirely, and it doesn't really overlap with software engineering. Yes, there are unicorns that have somehow figured out how to master both skills and an additional third domain, which is systems administration work. But this is not very common because just learning one of these fields is already very difficult. And the problem that data scientists are facing today is that they're using these traditional tools, which are built for the software engineer, not for the data scientist. And why are these disciplines so different? So although a machine learning model is a piece of software, it takes a fundamentally different approach compared to classical software engineering to develop a machine learning model. So on the left-hand column, you see software 1.0. This is what we're referring to classical software engineering. And on the right-hand column, you see software 2.0, which is what people are commonly calling ML engineering today. So if you're a software engineer, I'm sure you're used to developing software on, let's say, a 4-core CPU. There's no reason that you would normally need to wrangle terabytes of data. And let's say you're developing in C++, your compile time is within seconds. And the errors that you deal with are mostly logical errors. So you can debug your code using printf statements or debugging tools like GDB, depending on your language. And this is the paradigm when it comes to classical software engineering and developing software. When it comes to developing a machine learning model, dealing with terabytes of data is something that's very common because the more data you have, the better your model is. And that's why data is a first-class citizen when it comes to machine learning engineering. And if your model is on the order of billions of parameters, which is the case with these large language models today, you can imagine that your computation scales to the order of petaflops or more, which is a lot of computation. So this is a very computationally expensive thing to do. And usually a CPU won't cut it. You need a GPU, a TPU, a cluster of GPUs just to train your machine learning model. And because it's so computationally expensive, your compilation time, or the time it takes to train your model, is very commonly weeks or longer. And this is standard. So if you're training on one GPU, this is a standard model training time. Even if you have a GPU cluster, A lot of teams can't figure out how to use distributed training given a powerful cluster. And that's because distributed training is a non-trivial thing to set up. And we'll talk about that a little bit later. But compile times of weeks or longer. And then we have this idea of accuracy when it comes to developing a machine learning model. So the end goal of developing a model is usually performance on some task with respect to a data set. So these are not logical errors like classic software engineering errors. These are more probabilistic things that you see as you're training your model. You need to monitor your model losses, your model accuracies on certain data points as you're training, and you use tools like TensorBoard or other visualization tools to help debug, quote unquote, your model. So hopefully this convinces you that machine learning engineering is a fundamentally different approach. And you can imagine that machine learning engineers run into a whole slew of different problems than software engineers do. And right now, the problem is that they're dealing with both types of problems, both the machine learning model debugging issues, as well as the underlying software problems, which is a lot for one engineer to handle. So now that we've talked about that, let's examine where we are in the industry today. So what is the state of deep learning tooling today? So let's say that you're a single data scientist working for a biotech company, and you don't necessarily have a big team, you're just developing models on some data. So I'm sure you all have heard of tools like TensorFlow, PyTorch, Keras. So these are standard deep learning training frameworks. And a data scientist will often get started with one of these. And they will probably develop a small model using a GPU on their laptop or a single on-prem GPU. And this infrastructure is, it's annoying to manage, but it's relatively simple, it's doable, it's manageable without additional software. If you're not in a big team, there's not necessarily a reason for you to share your results or productionize your results. So you can be sufficient with ad hoc experiment tracking. So you can log your metrics in a log file. Maybe you save your model checkpoints with a name that specifies what hyperparameter search was done to achieve that model. And you can basically get by with this. So all of these things are small and simple at a small scale, and a tool like TensorFlow would probably suit your needs. But the real challenge comes when your team starts to scale. So this is when you have multiple colleagues, maybe you're working on a bigger cluster, everyone is using a different choice of framework. So the problems that you had at a very small scale become much more difficult and near impossible to manage at a large scale. So let's start with sharing your GPU infrastructure. There are ad hoc ways to manage this. I've seen teams literally put on a schedule who's allowed to use the GPU on what day. There are people that kick off their colleagues' training job when they need to use a GPU, which will get the job done, but that's kind of rude. So GPU sharing is a difficult thing to manage. Experiment tracking, if you're working on a big team over a period of months or years, reproducibility does now become a concern. So the ad hoc experiment tracking is probably not the most efficient way to share results with your colleagues, and things can get very confusing. Hyperparameter optimization is done in an ad hoc way a lot of the times if there's no tool support. Even if there is tool support, everybody has their own choice of library to use for hyperparameter optimization. It's hard to translate between colleagues. And then distributed training is something that's really difficult to set up. A, because it's just hard to learn how to port your code to the infrastructure. And B, because fault tolerance is a thing. What happens when one of your GPUs dies mid-training job? So it's hard to configure and also hard to maintain. So distributed training is usually reserved as a moonshot goal for a deep learning team. This is something that is bonus points. It's not necessarily included within the scope of a project. So these are the challenges that surface when you're doing ML at scale with a big team over a long period of time. And this is when the value of determined starts to really shine. So now let's explore how determined and the HPE machine learning development environment solve this problem. So here's where determined AI sits. It sits right in the middle of data storage and ETL and model serving. So on the left side, when we're talking about data storage, you think of things like Pachyderm, Spark, other tools that help you manipulate your data before training a machine learning model on said data. And then after you train your model, you need to export your model, deploy your model to run with some web service or app. Tools like Seldon, SageMaker, TensorFlow Serving help you accomplish that purpose. Determined AI sits right in the middle and really focuses on the model development and training process. So basically, Determined AI removes all of the infrastructure code that you need to normally write when doing any of these functionalities you see here in the purple boxes. So at the very base level, cluster sharing and resource management. So Determined handles your GPUs for you. And this can be done on premise or using a cloud provider. For example, if you're using a cloud provider, you can install Determined on the master node. If you submit an experiment, Determined will then provision the appropriate resource for you. Your experiment will run. Once your experiment is finished running, the resource is idle, Determined will terminate that for you. So this is something that is difficult to manage. This is an infrastructure problem, and Determined is able to manage those resources for you. And then on top of that, Determined offers a slew of features that machine learning engineers specifically care about, and things like hyperparameter search, distributed training. I'll talk a little bit about a few of these. So hyperparameter search is a difficult problem, and that is it comes down to figuring out what the optimal configuration for your machine learning model is. And this can involve things like model layers, the learning rate that your model is using to be trained. And there are various algorithms to figure this out. So one of them is random search. You can randomly search through a set number of values. There's a grid search. So you can, this is the most standard search. And there are advanced hyperparameter search algorithms that are difficult to set up, but do a much better job. So for example, the successive halving algorithm, you start with a bunch of trials, you prune the ones that aren't doing so well, you continuously prune them until you are left with the best trial. So Determined offers one of these state-of-the-art algorithms, adaptive ASHA, and this is available out of the box. So it's just a matter of a configuration setting when you submit an experiment. And already you can see that this is taking away a lot of work for a machine learning engineer to have to set that up themselves. So hyperparameter search is one such offering. Determined takes care of model checkpointing. So checkpointing refers to saving your model during the training process and then saving the best model. Best model can mean a lot of different things. And when working without a solution for checkpoint management, a lot of the times you will save every n number of epochs. So you'll save files throughout your training process. And this results in a lot of different issues. How often should you save your checkpoint? Do you have enough space on your shared file system to handle all of those files without pruning the ones that are not necessary throughout the course of your training experiment? And what do you consider the best checkpoint? Things like that. So Determined offers automatic checkpoint management. So over the course of your experiment, just another configuration setting. So you can specify whether you want the best model from your experiment or your trial, and it will also automatically prune the checkpoints that are no longer relevant for you. So another feature that removes the need for engineers to develop this infrastructure. And then I think the best value out of Determined is this distributed training feature. So distributed training, as I mentioned, is notoriously difficult to set up. When you're using one of Determined's high-level APIs, running distributed training is just a matter of telling Determined, hey, I want to distribute training across n number of GPUs, assuming that those GPUs are available on your cluster. And that is really a game changer. And Determined handles fault tolerance as well. So when one of your GPUs goes down, Determined is able to handle that gracefully and continue the training process. So there are a lot of different other things here, like metric logging. Tools like TensorBoard offer things like metric logging. Determined has a natively built-in metric tracker in the web UI, and you'll see that later when I give the demo. But hopefully this gives you an overview of what Determined offers and how it really focuses on solving the problems of a machine learning engineer. Last thing I'll mention, you see at the top here, all of these different engineers are using different frameworks, TensorFlow, PyTorch, Keras. So Determined is framework agnostic as well, so you can use your choice of framework. And then we have, like I mentioned, high-level APIs to support PyTorch and Keras, and then we have a low-level API that can integrate with any choice of framework. Okay. So now that you have a general idea of Determined and its offerings, I just want to transition to talking about the ML infrastructure landscape a little bit more broadly. So top tech companies, when you think of these tech companies like Google, Facebook, Amazon, they obviously have custom built internal software infrastructure to handle all of this for them. And that gives them an advantage. They're able to empower their deep learning teams this way. And that's great for them. But this doesn't really help anyone else. And nowadays in the industry, since there is this huge push for data-driven applications that are all dependent on AI, everybody needs infrastructure like this to develop their stuff too. And right now, a lot of the times, deep learning teams in industries like biotech, aerospace, researchers at labs are left piece open source technologies to try to build their own stack. And that can result in a lot of frustration. Like I mentioned, all these issues, distributed training, checkpointing, hyperparameter search, are heavy lifts, and that can lead to unproductive, frustrated deep learning teams. A lot of the times, deep learning teams will fail just because of the lack of good software infrastructure. So one of the goals of Determined is to provide the same world-class level deep learning software infrastructure that are available at these top tech companies to everyone else, since everyone is doing AI. And we're not the only one who is putting out new software infrastructure for deep learning. Lots of people are doing this. And especially in the last 18 months, the AI tooling market has grown tremendously. And this is because, like I mentioned, this technological shift to focusing on data-driven solutions. So we're seeing a lot of closed source proprietary solutions, open source solutions, all emerge at the same time. And this is really awesome because this is actually what we want. We want more software that is catered to the data scientist. But this also results in a different problem, which is a lack of common standards. So now there are all these tools flying around, but it's really difficult to figure out which tool to use for what, how each tool interacts with the other tool. So this cross-platform interoperability is a huge problem. And figuring that out can be very challenging. And this picture here is an attempt to show this idea of a Cambrian explosion in the AI landscape. So that is the state of where we are today. And at Determined AI, we believe that OpenStacks are the way to go and one of the ways that will simplify this space and eventually solve this problem. So one of the founders of Determined AI and now the chief product officer at HPE, Evan Sparks, gave this same analogy when we talked about this at GTC, which is that the LAMP stack emerging for web development. And this is about 20, 30 years ago when web developers were developing from raw HTML, first principles, and web development was super slow. And once the LAMP stack emerged, which is Linux, Apache, MySQL, and PHP, web development was drastically transformed because now everyone is using this canonical stack for web development, and it really drove the industry forward. So what we're seeing right now with AI/ML is the same thing. So we're kind of at the same junction where machine learning engineers are developing with Python, tools like TensorFlow, like deep learning libraries, but there's no real canonical stack for the entire ML lifecycle, which encompasses data processing, model training, model deployment. So we're hoping to see the LAMP stack, something like the LAMP stack for AI emerge, and that is what we believe will drive the industry forward. And real quick, I want to touch on why open source is important. A lot of the questions we get are around why does it matter that the stack is open source at all? Why does open source result in success? So it's really about this idea of standardization. And standardization encompasses a lot of different things. First and foremost, reproducibility. So reproducibility is very important, and having access to the exact same infrastructure as everyone else makes that a lot easier. So if company A is developing a model, they use Hyperband, which is state-of-the-art hyperparameter search algorithm. Company B doesn't have access to said algorithm, it becomes really difficult to reproduce that result. So if every part of your stack can be inspected, opened, understood, it just makes it a lot easier when everyone's speaking a common language. This is very much related to transparency and trust. So businesses and consumers trust open code because this is open for public review. Security flaws can much more easily be spotted when code is open source. And this transparency is really important when it comes to trust. Businesses can also adapt open source code. So just because they have access, if they need to adapt the stack to suit their needs, that's something that businesses can do. And it prevents vendor lock-in if they're using a proprietary solution instead. And then one of the feedback that our founders got when they were first developing Determined before it was open source, with the help of the best ML teams in the whole world, the feedback they got from them was, we want to use the same stack across career changes. The machine learning engineers today, they change careers every 2-3 years. If you're using the exact same stack that you use at company A, at company B, you can imagine that this skill transferability is something that has zero downtime. So that makes ML engineers a lot more productive. And altogether, these benefits of open source and open stacks, you can see how this drives the industry forward and makes machine learning engineers more productive. So that's the importance of open source. And right now we're still early in the industry, but we're already starting to see natural stacks emerge. So Pachyderm, for example, is kind of like a Git for your data that integrated with machine learning development environment / determined AI. And then Kser for model serving is one such example of this open stack. And people are calling it the PDK stack. So this is just one example. And importantly, at HPE, we're not just focused on AI and ML. We know that we want to integrate with the broader landscape. So this includes data processing, deployment, and we want to remain maximally flexible. So that is why we've partnered with the AI Infrastructure Alliance, or AIA. And at the AIA, that's what they're trying to do, is develop this canonical stack for AI ML development. And the way that they're doing this is promoting a healthy competition of modular stacks. And hopefully the idea is that one of these stacks will emerge as the LAMP stack for AI ML. But building the LAMP stack is really hard to do. I gave you one example, but it's not that straightforward to understand what tools can come together to build such a stack. And why is that so complicated? A lot of the times when people think about the ML model development lifecycle, they think of these 3 buckets: data prep, model training, model serving. I did not help when I showed you the PDK stack, which is exactly like this. But this is obviously a very, very oversimplified diagram. You'll even in more simplified diagrams, you'll sometimes see iterations where you retrain your model, reprep your data. But when you see new tools that are emerging in this space, sometimes they're just oversimplified, and classified in one of these buckets. And the reality is that it's much more complex than that. Each of these tools do different parts within data prep, different parts in model training. Sometimes they overlap between these 3 buckets, and different tools fit together in much more complex ways than this. So that's why it's difficult to figure out what the landscape looks like and how you can build these open source stacks. So this is what the AIA came up with to try to solve this problem. And you can see here, this is the blueprint. It has 20 or so buckets. It's not it's much more complex than what I showed you on the previous slide. The way that AIA came up with this is they had 50+ companies join their organization. So they went in and analyzed what each of these companies are doing to come up with this blueprint. And this makes it really easy for a company to go in and highlight what it is that they offer. And this makes it easier for you to figure out how different companies' offerings can fit together. So this is super cool. On the left side, I don't know if you can see this, it might be a little too small. We have Pachyderm, Seldon, ClearML, but here's a zoomed in version of the PDK stack, like I was talking about earlier. So you can see exactly what Pachyderm does, exactly what Determined AI does, exactly how it integrates with Kser. And this just makes it easier for you to build your stack. If you wanted to add additional projects in to handle the parts that are not filled in, that's something you can do with this interactive blueprint. So this is a really cool initiative by AIA. And just to conclude this portion of the presentation, open source is really important, and we believe that this is the way to drive the industry forward. So if you are interested in joining the AIA, we'd really love to have you join us in this mission. And now I just want to talk a little bit about Champollion. This is not related necessarily to open source, but this is just something exciting that we're able to offer as part of the stack. So in partnership with NVIDIA, HPE has built this supercomputer called Champollion, which is housed in Grenoble, France. It is a beast. It has 160 NVIDIA A100 Tensor Core GPUs, really powerful GPU. And right now, this is just used as a test bed and a resource for customers, latest and greatest technology. And Determined is really able to offer the best support for customers who are using this supercomputer, just because our Determined's DNA is in distributed training. That's what we were doing from day one. So this is just an example of something that we could offer as part of your standard stack. And our business strategy is to support your OpenStack. If you're already using a machine learning development environment and you're interested in scaling up, going into production, this is something that might be of interest. So just wanted to touch on this. And here is a picture of that. It is located in Grenoble. Would love to see it someday. So that concludes my slide content. I do also have a demo. If we have time to go through that.
Yes, there is time for this. There is a couple of questions. Maybe you want to take a few before you go into this. For example, there's a key. What are the key differentiators with Kubeflow, MLflow? That's one from Cedric.
So
and
the key
from SageMaker, AWS SageMaker. Another question.
Sure. So the key differences from Kubeflow and MLflow. So I would say that MLflow is pretty similar. I know that it's about in the same space. A lot of people do use Determined and MLflow together. I don't know the details of it too much, so I don't want to speak on it too much. But I can definitely redirect you to the right people to give you more details. Kubeflow, as far as I know, it's mostly for running on top of Kubernetes. So I think that's the main difference. But again, I can redirect you to the right people to give you a little bit more details. As far as I know, SageMaker is limited to running on AWS. So the thing for Determined is that this is cloud provider agnostic. But again, if you're interested in more details, I can redirect you. So each of these different solutions are about in the same space, but there are key differences, and it really is worth taking a closer look at how Determined is different. What are the next questions? Let's see.
There's a question about access test resources, but that's from, I guess, from internal HPE. So I don't know if you have an answer for that, but we can keep it offline or otherwise.
Yeah, we can maybe take that offline. Yeah. Seeing a question about heterogeneous device configurations. I'm sure that's configurable. I think that would be something we'd have to talk to an engineer about directly. I don't know off the top of my head, but I wouldn't be surprised if that's something you can set up. Determined AI is available as a cloud-based offering or on-prem.
Mm-hmm. Yeah, Alex answered also a few questions for while you were talking, so thank you, Alex.
Yeah, thank you, Alex.
I think you're done with the questions.
Okay, sounds good. Cool. I can give you a quick demo just so you can see what the web UI looks like. Let me zoom a little bit. So here is just a really simple example of using the PyTorch API to train a convolutional neural network on the CFAR10 dataset. CFAR10 dataset is a computer vision dataset with 10 classes. I think they're classes like dog-cat, just standard image processing classes. And how you utilize one of the high-level APIs like the PyTorch API is by implementing a subclass of the PyTorch trial. So what this means is just telling us what your model definition is, how to train one batch of your data, evaluate one batch of your data, and how to get your data. And this is the only lift that we ask you to do. Once your code is ported to one of these APIs, all of the features that I mentioned, like distributed training, hyperparameter search, are available kind of out of the box. And I mentioned a configuration file as well. So this is the standard way to pass in your configuration. You can also use command line, but this is something that's easier to see. So if you're running a constant experiment with static hyperparameters, this is what your config file might look like. You can define the name of your experiment. You define a static learning rate, layer, dropout layers, and then you basically point to your entry point, which is where your model is defined. And just given these two things, that's all you need to submit an experiment to determine. And what you can do is use the command line interface to submit an experiment. It looks like this. So this is that experiment create, pass in the config file, and then pass in the directory where your model code is located. So that's just my current directory. Submit that. And you also have to have your master node configured in the determined master variable. So just show you that. This is how you specify which cluster to use. This is just the IP address. So I've submitted my experiment, and let me show you my other screen where my experiment's running. So this is what the web UI looks like. Are you able to see a graph? So this is kind of the list of all of the experiments that you submit to your cluster. This is the one I just submitted. This is currently running. I'll show you what a previously run experiment looks like. So this is the constant experiment. You can see that the validation error is being plotted here over a set number of batches. In the web UI, you can also examine what the code configuration is that you submitted. That's really easy to see. There's a log tab as well to monitor your experiment. This cluster tab shows you how many CUDA resources you have available, master node and agent nodes. And so this is really cool. And let me go back and show you real quick the adaptive search and distributed parts. Hopefully sharing the right screen. So this is the constant experiment. I mentioned that it's just a matter of changing your configuration setting to run a hyperparameter search. So here's an example of that. So here you can see that these hyperparameters are static. Modifying your hyperparameter search to look something like this, where you define a range, is something that's very easily changeable in your config file. And then you can also define a searcher. And Determined offers this state-of-the-art hyperparameter search algorithm, adaptive ASHA. And that's really all you need to change this to a hyperparameter search experiment. Same thing with distributed training, just setting slots per trial to a number that is less than your total number of available slots to train on. That's all you need to change to configure distributed training. So you can see how easy it is. This is using Torch Horovod and Torch distributed because we're using the PyTorch API. So that is all you need to do, and submit the experiment the same way, but just define your config file as something else, for example. So looking at the web UI again, so we'll take a look at the adaptive search. And you can see here adaptive ASHA so some of these trials were early stopped due to not performing as well, and some of the trials persisted through the end of the experiment. So that's really cool. There are different ways you can also visualize your hyperparameter search, scatter plots or heat map. And then same distributed training experiment that has already been run. And if we were running distributed training right now, you'd be able to see that 4 out of the 5 CUDA slots would be allocated. And that is about it. So that's all for my demo. And hopefully this gave you a good overview of Determined and practical usage in the web UI. So I'll take any more questions now.
Thank you, Isha. There's a few more questions in Q&A. If you want to take a look.
Sure. So about this scalable data versioning and model versioning tool, I think Pachyderm would be the best solution for scalable data versioning and model versioning together with Determined. This would be a good question for that you can ask in our community Slack channel. Let me put that on the slide right now. I can connect you with the right people. And then provide a platform for. Yeah, so I believe that the enterprise version would be the right way to go without having to worry about infrastructure maintenance, because we provide enterprise level support for MLDE. So let me put the link to connect to our community Slack page on the screen.
So this is the answer to the question in the chat, right?
Yes.
Okay, there's a few more for you in the waiting in the Q&A window if you open that one instead of chat. I don't know if you have that one.
Sounds good. Let me just put this on the screen. So that is. So that link will provide the purple QR code is for a community Slack. That is the best way to get in contact with people at Determined directly. See. Early stopping with the adaptive ASHA, there are details on the docs page, but these are trials, like it basically early stops half the trials or 1/n number where you can specify any n early successively until your experiment is complete. There's a way that adaptive ASHA defines exactly which trials to stop. It's usually like which losses aren't performing as well. What GreenLake model is supported? That is a question that I would have to check with our infrastructure team to answer, but you can also ask directly in the community Slack. Sure that they would be able to provide you a better answer.
While you answer the question, I will start the end of session poll so that I see people are dropping. So don't be afraid.
Okay, sounds good.
In the middle of your screen, that's why.
Yeah.
Thanks.
In the middle of the screen.
You can move it around.
Sure. Yes, I believe you can do a neural architecture search and hyperparameter search in the same experiment. I haven't tried that yet, but again, community Slack will give you the answer to that for sure. Let me click on this link. Unify AI. If this is an open source framework, I'm sure that this is something that would be relevant to Aya. This is for Unify AI. But I'll take a closer look at this and definitely open up a discussion in the community Slack.
Okay.
HPE related, where it went to position MLDE, Unified Analytics, MLOps. Okay, so Alex is answering that. If you're cloud agnostic, is the concept of billing for large training jobs considered? Decide run on. Yeah, that's another question for our enterprise team, probably, Sean. So definitely ask in Slack.
I'll try to get you the link in the.
Yeah, let me paste the link in there. Oops. I'm going to stop share for a second.
Hey, Isha, I just posted it in the chat for the Determined Community Slack.
Okay, awesome. Thank you.
Thanks, Alex.
Okay, putting the screen back up. Is Determined AI part of GreenLake offerings? It's GL stands for GreenLake, I presume. I'm not sure. I would have to get back to you. Or Matthew seems to know.
All right. Seems
And
like
I just figured I'd, Isha, answer a question from Heman regarding hosted infrastructure. So the Determined team is pretty actively working on a version of Determined that is hosted. The easiest way to stay up to date on all of these topics is basically like Isha's been saying, a mix between the Determined community Slack and the HPE internal Slack if you are an HPE employee. So we can post the relevant links either now or after the session.
Thank you, Alex. All right. I think we don't have any more questions. So I would like to thank you, Isha. Thank you, Alex, for helping with the questions. And thank you, everyone, for joining. We give you a few minutes back, and we'll make the video recording available in the next couple of days, and the slides as well on the Meetup page. So with that, thank you, everyone, and have a great rest of your day.
Thank you.